Welcome back, I'm Professor Steele, and today we're going to look at our thinking problem using the law of sines. So the problem has been set up. We've got a US Coast Guard station located 180 miles west of another station. A signal from a ship in distress is received by each station. The location of the ship is 31 degrees west of south from one station and 38 degrees east of south from the other station. How far is each station from the ship? So in order to set this up, we should draw a diagram. Okay, if we recall, north, south, east, and west. So we have the two stations 180 miles from each other. That's the first thing we can sketch. Now, so there's that first piece of information. Second piece of information, the ship is 31 degrees west of south. So we've got to pay attention to which side is that going to correspond to west of south. If I draw in my south at both these stations, I'll note that if I'm going to go west of south, that would be in this direction. So clearly we can't be talking about that direction in terms of this station. So my 31 degrees is in this space. So let's see if that adds up with the next piece of information. The signal is 38 degrees east of south from the other station. So again, if this is south, 38 degrees east would pivot it towards the east. So that tells us this measurement is 38 degrees. So we want to know where the ship is. And here's our ship. So we are trying to determine this measurement, let's call it A, and this measurement, let's call that one B. So now that we have these two angles, we can determine the third angle in our triangle. We know that the sum of angles in a triangle is 180. So this measurement, we can call this angle C. Angle C is 180 minus the other two angles, sum of the other two angles. And that leaves us with 69 degrees. So this missing angle is 69 degrees. We have the side opposite that angle. So if we've labeled this as A, this as B, this will obviously be side C. So we have the measurement for side C. We need to find the measurement for side A and B, respectively. So we can set up our law of sines. Side A divided by sine of the angle A is equivalent to side C divided by sine of the angle C. If you'll note, I've written our law of sines with the angles in the denominator because I want to determine the value of our side. So putting in all the pieces we have, A divided by sine of 52 degrees is equal to 180 divided by sine of 69 degrees. Try to get our A by itself, isolating it, we have A equaling sine of 52 degrees times 180 divided by sine of 69 degrees. And that measurement is 151.93 miles. So we've determined how far the ship is from this station. Now we do the same thing with our other side. So I'm just going to set this up with side B and side C, since those are the values we have. So side B divided by the angle B, which is 59 degrees. Now, you may be tempted or questioning, why couldn't we have kept it with A divided by sine A? Which is a legitimate question. But here's the thing, if we were wrong in our calculation on side A, now we have an incorrect answer that we're working with. So always use the given information, which happens to be the 180 and the angle 69 that we determined. Similarly, as before, we're isolating for B. So we have B equaling 180 divided by sine of 69 times sine of 59 degrees, making sure our calculator is in degrees, and B is approximately 165.27 miles. So we've determined the two distances that the ship is from each station. Thank you for watching. Make sure to like and subscribe to EdVantage, and we'll see you next time.